Hello, good evening. Hello, I just hope you guys are able to hear me. You can confirm with me in the comment section if you're able to hear me so that we can start. Just confirm with me if you're able to get me loud and clear. If my voice is clear also, it's not distorted. Just confirm with me if you're able to hear me. Wonderful, wonderful. Yes. On TikTok, I don't know. We don't have people yet on TikTok. Nice. So we are going to start in the next 3 minutes. Take this time to invite someone. We are still on this fraud detection system. This is part 3, and we are going to cover a lot today. Actually, I've been unwell, that's why we didn't have a session last week, but now we are okay. So we are going to cover a lot today. So just take this time to invite someone. We are going to start in the next 3 minutes. Actually, the Kenyan time that should be 8:10. The next in the next 3 minutes or 2 minutes, just invite someone. Share with someone the link. Share with someone the link. Remember, everything here is free, and I'll be taking also the question in the event. For example, you are not understanding, you can always ask. So it is live. That's why it is live, so that I can get your questions live. And also, you can correct me. You can correct me in the event, for example, I'm not doing it right. So take this time to invite someone. Invite someone. Wonderful, wonderful. I see Facebook, we have 4 people. You can invite someone. We are starting now. In the next 2 minutes, we are starting. So as we wait, last time in the past 2 sessions, the first one we began by importing the several libraries that we'll be using. We later loaded our datasets with pandas, and we did some basic exploration of the data, and then we did also some EDA, the EDA there, and then also some data cleaning. We started data cleaning last time, and we were handling the missing values. Data cleaning, but then on the missing values, to handle the nulls. Nulls, you can handle them by either replacing with some data or maybe doing away with that record completely. Doing away with completely those records. But then for us, we did several steps here. Like the first strategy for the categorical column, or those columns that do not have the numbers, we were filling it with the unknown. We started with those ones. So we did a list of those columns, and then we replaced them. And then the second strategy was on the numerical column. And for this one, we were actually filling with the median. Why median? Because if you will fill with the mean, and let's say there's an outlier, like there is a big value maybe which is out of range, if you have such a case, then the median is going to affect what is going to affect and assuming that you have a lot of nulls, then it's going to have a data set is not going to be more reliable in the event, for example, there's an outlier. So using the median at least is will not have big impact, big effect. And then for the other one, we were to tackle the IP address, and this one we just filled it with the this one, because this one required a lot of value computation. There was a lot involved, because this one is not like a numerical, nor we couldn't fill it with unknown. We tried to have something there for the unknown IP addresses. So this is where we were last time, and let me hope we have a good number. This is wonderful. Yes, so I think now we can start. So today we'll be continuing. We said last time we were tackling the missing values, but now also on the messy data, not only the missing values, the missing data could be, for example, if you have the outliers as well, or maybe if you have the duplicates, or maybe and those other things. But now, before we get there, we just want to format first of all the data types for the column. We just want to make sure that all the columns have the correct data type. Like there's that column which was storing. Let me see if I can try to open. I hope sharing my entire screen. So basically, there was okay, like we've tried to format it to fill it with some proper data, those nuts. But then maybe there could be, I don't know why it's taking long to load. We want to just make sure that the columns are storing the correct data types. If it is numerical, should be storing there. Yeah, so like you can see, this one, in the event, for example, we have something like this, although we cleaned this one, but in the event, for example, you have any text in a numerical column, if you want to use if you want to use NumPy, then it's not going to work. Remember, NumPy stores data in a continuous memory, so it wants if it is numbers, it's numbers. If it is text content, it is text content. So the idea of fixing these data types is to make sure that we are sure about the data types of the columns we are going to use, because remember, there's some point we are going to use NumPy, and that one is very sensitive to incorrect data type. So let me write here. This should be now step 4. And by the way, in the event, for example, there's a question, you can share it in the comment, or have a concern or anything. You can always share it there in the chat. And also by there, you can if you haven't subscribed, subscribe also, so that the YouTube algorithm can recommend the video to other people. Remember, we want to make sure that most of the people at least have some tech skills. This is free. So this is part 4. Maybe we can say data cleaning, but then now this one we are going to handle, let's say, fixing data types. Fixing data types. And then for the numerical column, it's this one. Let me just copy this one. Let's start with the numerical column to make sure that they are correct data type. Now, first of all, I will need to run again this code so that it can be in the memory I've just imported. I've just loaded the notebook, so I will need to run it so that it can be in the memory. In fact, I will need to run everything. What I will do, let me use this run all cells, because remember, all these changes we are making, they are only being applied at the pandas data frame. It's not like on the data set, it is just on the data frame. So it means that anytime you'll need to use the latest changes, you'll need to rerun again every other thing so that you can apply again. It doesn't affect the original data set, so it's just the data frame. So we are here. And then we want to fix numerical column. Let me just say this is to fix the numerical column. Fix numerical column, which might be stored as strings, perhaps. We are not sure about that, but just fixing numerical columns may be stored as objects, as strings. So remember, we are doing this one because there's some point we are going to use some NumPy, and it's very, very sensitive to those data types. Now here, since we have listed most of the this numerical column. So we have there. Now let me just check this column. We also have amount. It's also a numerical column. I think I can use this other one. I can use the data set directly. It's much easier to copy paste. So we have the user age. Where is it? We have the we have the these things are quite. Let me try to make it more readable. Just a moment. And this thing is not opening. So so we have the transaction date. That's not account age type, card type. User text, user age, account age type. This number. Let me just account age type here. So let me just copy also this one. Account age type. Now again, we say that we are going into details this way because we might be having a beginner, so we want to like just go through everything. Then what else? Maybe transaction count. This one also, it should be taken out the numbers or numerical data. And then let's see what is average transaction. This one is also, I don't know if it is there. Average transaction amount, yet it's there. It's there. And then average transaction amount, yeah, it's there. And then let's see, distance from last transaction. I'm not sure if it's there. Distance, yet it's there. We also have the merchant score. Merchant score. Let me just confirm. Merchant repetition score. A merchant repetition score. So I think, and then now this the final. So these are the numerical column, and we know they are at the moment numerical, but then now we want to just make sure that it is numerical, and we can iterate over them. Using a for loop. Individual column will be using a variable column call in this numerical. Let me just call it numerical column. Column, a numerical column, in numerical column, and then now we'll do a check. For example, before we update them, we can try to check first. So, for example, if call is available in the data frame. Remember the data frame we stored in the variable df. Just for in the event, for example, there's someone who is new here, like joining us for the first time. So we use the variable df for the data frame. So if that column it is available in the list of columns, and then let's say original data type, D type, original data type. It will be original data type. It will be original data type. It will be now the data type for this individual column here. So we'll be using now this D type is like a method, not a method actually. It's an attribute or a parameter to check what the data type of pandas. Remember, if you're on NumPy, it is slightly different. It's a method. If you are on NumPy, but in pandas, it is an attribute. Just like d type or a parameter. Yeah, d type, and then df column targeting out this individual column here. I don't know why I usually copy these small things that I can just type, Yeah, so, and then so for this individual one, then we will be first of all addressing the event. For example, this some error, like sometimes there are some, we have done the cleaning, but then for example, if there was a column, if there was a column which was supposed to, I think this one we did the other time, we did it here. For example, if there's a column which is storing still numbers, but it is in strings. Like, let me show you something. For example, if you have something like 1,000, this is a number, but it's only that it is formatted in quotes, in strings. So, like, we can use the same logic like what we did the other time. We are repeating the same thing. We know that one is fixed, but now just to be to be sure, or maybe just to explain it again, let me just redo it here. So this one is just to make sure that the numbers are real numbers. So this one we are targeting this one, and then we're using these pandas2 underscore numeric, so that to make sure that all numbers, they are indeed numerical. They are indeed numerical by using this class here, which is going to convert them into proper numerical. And then now we have done also the filling of the nulls. In the event, for example, in the process, there has been a null. What we can do, we can right here fill any. Actually, what we are trying to do here also is to also make sure that this code is reusable. It is reusable. Such that in future you just need to run everything, and then it's going to be sure. So, for example, if there's a null, which is a null, like the data type, it is more of a, is it data type? It is NaN. Now, if you are an SQL, it is usually null, but now in a notebook, it's nasema NaN or something like that. So in the event, for example, there are those new values, maybe values that were created, maybe during the conversion process here, any new non-values can be created during the conversion. Errors. We are still together? Confirm with me, guys, if we are still together. Just type there, we are together. We are together. Just say we are together. Confirm with me. I'm still on YouTube, still showing the count. I'm not sure if I'm still live. Okay, wonderful, wonderful, wonderful. That's great. Wonderful. Yes. So, in the event, for example, during this conversion, we had maybe a new null, then we can as well address it. We can do it iteratively. Let me just find. I'm used to not repeating things. By the for us machine learning engineers, we want to make sure that we are automating repetitive things. So now mine is not automation, but just to to copy paste. So here basically I can fill with the median as well. And remember, if you're going to use this in place too, it means like it's going to update like at the database. It's going not data frame. It's going to update now the original, or maybe the pandas data frame. When you use this in place, then it's going to affect the original data frame. So first of all, this one we are trying to check if there are those nulls. If there's a there's a null, then if we find there's a null, then we're going to apply this one. Remember this, the if statement only check if it is true. So here we're trying to check first of all if they are indeed null, and if they are nulls, then those are the things that we're going to affect them, and that we're going to fill it with the median. And the reason we are using the median, it is because I explained earlier, this one is not sensitive to outlier. So here I can print something like in the event it was successfully converted, then we can use, we can say something like a converted. Now this is unnecessary, but now for someone new, you want to be organized. I'm doing this one intentionally. These things you can just, it's not, okay, let me just use this original type here. Original type it was maybe this one. And then now to a new data type, which is now, it will be now df, the data frame, and then now those columns that have been modified, and then their data type. Now here we're using d type. So like at least to tell us if there were some columns that were updated. Now we can be sure, we can be 99% sure that these things were fixed earlier, but just for confirmation, we are doing it that way. And then maybe we can try to as well fix another thing. It is, there's a date column. There's a date column somewhere, transaction date, it was somewhere. It is transaction date here as well. We want to just make sure that it is in the correct time format. So this is recording the time. It is recording the time, and by the way, keep sharing the video so that we can have more people, more learners. And these things are actually, they are not hard, by the way. They are not hard. So anybody can learn. So just share it with anyone. So here we want to just fix the date column. And guys, you notice that for me, every section I'm trying to comment it. So this can be very helpful so that in the event, for example, you're collaborating with another person, they will not struggle to go through your code to understand what it does. But now the comments are going to help them at least know, especially data science, you'll not be working alone. Actually, this is just a simple project, it's a demo project. That's why we are working, you can be working alone, but then now in a real organization will be having, maybe you have the data engineers, analysts, we have those data visualizers who does the charts, dashboards, and all that. Then we'll be having the machine learning engineers. So we have the software engineers who will be now deploying your models on a mobile application or a web application or desktop application and all that. So you'll be collaborating with most people. So you want to make sure that your work is readable, like someone can understand what you're doing easily without the struggle of. That's why we are trying to, I'm doing it intentionally so that you can as well use the same flow. So here it is, let me find the column name, transaction date, transaction date. So this transaction date, I want us to make sure that it is in the correct. By the way, this is not a date. This is time, right? It's recording time. Okay. Let me just, I will use, okay. Let me see if this one is going to work. If it's not, then I'll figure out another way. So let's try to use this two from the pandas. to underscore date time. Date time, so they can be in that format, in the correct format. For the pandas, no, sorry, here should be now df, and then now this. In fact, let me just copy. And then as well, we'll do the same thing like what we did with the numerical. In the event, for example, there's maybe a record which is not proper date, then we can do it. We can restructure it to be in the correct time format, and then we can try to also log something, maybe converted the datetime correctly. In the event, for example, they will be converted, so this will be like a confirmation that they were converted. So let me say converted transaction date or something. Let me say converted transaction converted transaction date to sorry, date time. Then now we can try to verify everything now. We can try to verify everything after this one. After we've done all this, we can try to verify now. This one I'm expecting some bugs. I'm expecting some error. Verify. If we will not get an error, it will be a miracle. So verify data column, and then we can try to print something. We can. There's nothing to. Let me use a new line here. Maybe final data types, just to be sure. And for that, we'll use what? Which attribute? You can use the d type. So print data frame. Remember, we used in place. We used in place true earlier. So when we run this df dot d type, it will be d type. It will be now giving us now the updated now data frame. So d types. D types. Now in the event, for example, we want to know, remember the data frame is made up of several series. It's more than one. To check for individual column, I said for individual series or column, we call it type. Now for the entire data frame, we can be able to use these types. It has a plural s at the end. So let's run, and then I say that this should be data frame does not have an attribute called date time. To date time, let me first of all confirm. I think it has to pandas. Let me see. By the way, and inapanga method gani by the anyone there? I thought it should be inapanga kwa namba ya man. I thought in pandas. Sorry. Nana shida ni nini? I was using the data frame instead of the pandas. Sorry. Should be PD. Actually, the alias is PD. I think ningetumia jina ingine ya data frame, but now to change everything itakuwa tricky at the moment. Let's just maintain like at this PD in DF karibuni in changanya. So like at this the pandas itself, and then wonderful. None of the transaction date is now in the proper date time. Let's compare it with the before here. Should we do that? Not really, but now as you can see, transaction here, it was treated earlier as the string. Okay, let me try to just, I don't know if I can create a column somewhere. Let me try to print just to make sure this to confirm. I know you have already needed that. you are sure about that, but just to compare. This one it is before. Oh, okay, but then nothing has happened. Nothing has happened, but now we have done it well. We have done it well because let me confirm something. Okay, yeah. So it seems there was no even error, but now you want to just make sure that you are doing these steps, even if you are very sure. This is very very key. So here you can see now. By the way, you can see this user age. The one I was telling you. Um, oh, okay, all of them, they have actually seem there were no changes at all because all of them, you can see from float to this one, from float to this one, from int to this one, like there's literally no changes. And I believe this one is, we did it earlier, so everything is good. Now in data preparation, you just want to make sure that you are very sure about the data integrity. It should be very, very high. That's why we've done this one. And apart from just doing it here, we are also learning. That's why we had to repeat this one. So this is a very important step to make sure that the data type are in their correct formats, because if you're going to use pandas and no numpy, that one is very very sensitive to data type. Like it stores that in a continuous memory, and like for example the list which you a Python list. Sorry. Let me try to get the mouse. Um, all right. So I believe that as computer scientists, they know something about the locality of reference. Like basically a list usually store data. Unaona ziko separated and you can store any data type. For example, the text. For example, hello. Like a string, Python list can store any data type, and each one it is allocated memory, is allocated different memory for string. There's also another way it usually allocate memory. So now pandas, it is different. It stores it in a continuous place, and that will mean that if it is numbers, should be numbers. If it is strings, it should be strings, because the values or maybe the memory allocation for numbers and strings, it is different. So if you'll have those issues or maybe incorrect data type, let's say it is a numerical column, but then there's some text somewhere, then it's going to convert that entire thing to be text, and you can know if it is text, you cannot perform what? Some statistics or maybe mathematical operation on that. And that's why this step, it is very, very important to convert the correct data type. So that is the first thing we had to do. And then now the other thing, step four. Let me know if guys you are also understanding. Have you understood this step? Was it important? Was it necessary? By the way, now that nothing has happened, was it important? Was it necessary? We are together. Just talk. I know some of my students wananielewa. I usually want them wanna respond in every section. I believe wangu wanaboeka sana. Juu hizi vitu za online, sometimes you can think you are teaching, kumbe uko peke yako. So I usually ask them to confirm with me if we are together, if they understand it, before I continue. So here, the next step here now will be fixing by removing maybe removing duplicates. Removing duplicates here, and now this one is just straightforward. This one is not very hard. This one is not very hard. So before we remove it, we need to check it first if it is there. We need to check what? If there are any duplicates first. Let me say check. Okay. Check for duplicates. And how do you check for the duplicates? This one, Um, for the duplicates, we can use the duplicated method, which it will be returning true if there's a duplicate, and then false if there's no duplicate. But now since it will be like running everything, so that will be tricky. We can use the method sum, the duplicated, and then also the sum. Maybe we can try to count the initial, maybe say initial number of rows, so that I will see after we have updated if there will be some changes. So the initial rows, and by the way, remember, I intentionally made this data to be messy so that we can learn this thing. So here, we usually use the len function. Actually, there's something in Python objects or classes called polymorphism. Like a particular thing can work differently on different objects. Like when you use this len on a string, it's going to return the number of characters in a string. When you use it on a list, it's going to return the number of elements in that list. When you use it in a dictionary, it's going to return what is the number of elements which are in key value pair. So in this case, it is a data frame, can also be used here, and I want to know the number of records that are there, how many rows are there. This is the initial before we do anything. It usually executes code line by line. So it's going to execute this one first before the next line. So now the other thing, I want us to create the variable for duplicates, and then here um, we are going to use the method called duplicated. So basically this method, it is used to check if there's a duplicate, and it will be returning true if there's a duplicate and false if there's no duplicate. But now, since we don't want to have those true false, we want to do a count, we want to check how many of them are there. We can add in another method called sum from the pandas to check what? To get us the sum of those duplicates in the event they are there. And maybe we can try to print something in the event, for example, they are there. We can say, can use a formatted string because I want to use some variable somewhere. I can say duplicate. I say duplicate. What can I say? Let me use something like found. Found duplicates. So this one is going to show the scalar value of which should be now the number of the duplicates that are there in the data set. And then found this will be now a scalar value, and then now found duplicates, for example 20, and then here I can say something like a duplicates, duplicate rows. Let me say duplicate rows, and then on this one, if you want to perform like the conversion, do we need to do that? Okay, let me just do it. Like for example, in the percentage, so that we can know what is the rate, what is like the proportion of those duplicate values. So here, and by the way, in this case, I know there's nothing because because now it will be checking out the entire row, and there's a transaction ID which should be for every user. If there should be for every user. Actually, we know there's nothing there, but let's just do it. So here on this one, basically to convert it into the percentage, then I shall use the duplicates over the initial rows. Now remember, duplicates, they are in terms of these duplicates are also in terms of rows, how many rows are there, and then these initial rows like is the total number of rows that we have, which is around 210 or something, 210,000 something there or thereabout. Then now we can multiply by 100. Multiplied by 100, maybe we can use some few decimal. Remember, if it's going to be now in if it's going to be in percentage, and the proportion could be very small, so we can convert it maybe into two decimal place, and then now this is to confirm first, and then now the next step here we are removing. Yeah, you want to make sure removing duplicates. Removing duplicates. Wonderful. I see people are still there. This is great. Wonderful. Yes. So to remove it, then we use we are going to use we are going to use we are going to use the drop underscore duplicate. Drop, I think duplicate, something like that. Yeah, duplicate. Duplicate. But now when it will be removing the duplicate, we need to tell it so it can keep. Actually, when we talk about the duplicate, it means something repeats itself more than one. More than one, could be 2, 3, and more. So in this case, we'll want to say to keep the first one. So there's a method you can use there, keep, and then you can say for the first one, you write it there first. So in the event, for example, you are removing the duplicate, then you need to keep the first occurrence of that thing. For example, kama kulikuwa na ile, okay, sorry, I'm having international people. So like if you have the first row, and then you have the next one, so it is going to remove the next one, and then it's going to keep what? The very first one. So and then now we can try to do a count for the final row, final underscore, but this one I really doubt if there will be some change, because I know the transaction ID is very unique, but if there will be a change, that will be good. But remember, you just want to make sure that the data integrity is high. Then here we can try to print a verification message, maybe something like data, maybe dataset size, and dataset size. Maybe we'll be comparing to the initial rows, initial rows the initial rows here, and then versus the final one. So something like this one. The final one I will be using now the final rows, just to see this. For example, it was the number of rows that were there initially, and then the changes, the updates that have been made. Yes. So yeah, final. And by the way, I must not forget to thank people who in the last stream sent me something. I don't want to mention their name. I want to appreciate you guys so much. I don't want to mention your name, but I'm really grateful. Yeah, so this is the initial rows, and then now the final rows. Just a confirmation, something just to tell us the change, or maybe the initial set, and what has happened, you know. And maybe we can try to print another thing. Maybe let's try to print. Let's try to also print how many were removed. So let me say removed. Removed is going to be what? Okay, just a moment, guys. Sorry about that. So here we want to check like how many we have removed, and for this case we will be using now the initial rows. Initial row now will be now minus. Remember, these variables are holding values, so a value is able to perform arithmetic operation like subtraction. So this is initial rows, and then now we'll be subtracting those that were removed here, which it is on the final rows. The final rows, and then now because we are removing the duplicates, it means like the fields will be reordered. Like for example, if there will be a record that maybe there will be maybe let's say the record number 2 has been deleted at index number 2, then it means like it's going to count from 1, then 3, and so forth. So there's a method to reset so that it can be in the correct format to 1 all the way to the end without like skipping some index. So for that we can update the data frame df, then dot reset reset underscore index reset index, so that it can begin now to count 1 all the way to the very end, and then here we'll add the drop. We'll give it to be true. So basically this is just to like or I can write a comment something. So this one we want to reset reset the want to reset the index after removing rows. I want to reset them. So let's run. I know there's nothing that is going to happen here. Oh, by the way, there were duplicates. There were duplicates. Wow, this was very key because I was thinking there was no duplicates here. This step is quite important. We do it, and I'm getting the I'm getting the error. Let me just. This notebook is misbehaving. Yeah, so arrows. Let me see. Actually. Oh, okay. I know the reason. Because the reason is this one is affecting the original data frame. That's why when I've run it again, you can see nothing has happened. So what I'm going to do, let me save the notebook and then I restart so that we can be able to see the change. We cannot work it very hard and then we can't see anything. So like let me rerun it again so that it's going to execute. Actually, this one is updating the data frame, the original data frame. That's why when you run it again, there's no change. Earlier you saw there was some percentage. So here I want to restart. You don't need to do this one, just to confirm, guys, to someone, and then I'm going to rerun it again so that it is going to reset. It's going to reset. So let me run everything. Then I'm going to expect. After it's going to show a value here, it means that it will have executed. So we're going to give it a moment. We're going to give it a moment to run everything there, and then yeah. So this is what sorry. So this is the first step on the confirmation of the duplicates, and you can see these are 826 duplicate rows. So which means like this could be treated as a duplicate transaction. I think because we have those IDs. And transaction ID. Maybe there was a transaction that was repeated twice. You know, there's some point, especially I have used some particular system where they have integrated the payment gateways and they haven't like implemented the logic to check if there's an existing transaction. So you find that someone pays twice. Like it pays twice before you get what the message. Okay, like and then later maybe it can bring everything. So like these are those cases. 826 is not a small number. These are duplicate transactions, and it represents how many percent? 0.41. 0.41, and you don't know each transaction, maybe it was around a million. Let's just assume that actually we have at the data set, but now let's just put it that way. Let's say it is each transaction is 6 million or 10 million or a bigger value. You can see this is not just a number. This represents some serious issues. So could bring an issue when you train the model, but then now this one has been fixed. Now the reason we got zero last time, when you run it again, because it is affecting the data frame, when you run it again here, we're going to get what? We're going to get zero. So this is what we are getting earlier. That's why I had to restart the notebook so that I can demonstrate it again. So this step also, it has yielded something at least, not like at this first one, but it is important, guys, you do this step as well for the fixing the data types, because I said if you're going to use NumPy, perform those statistical summary or maybe some arithmetics, and then you need to have the correct data type. So this is on the removing the duplicates. Guys, let me know if it is clear up to that before I go to the next part. You're saying uh, they use oh, basically the user, actually what we are trying to check here mostly that we are focusing on, it is the transaction ID, because this is what should be a primary key. This transaction ID, the user ID, like a user can make multiple transactions, like can make multiple transactions, but now the transaction ID, this is what is tracking. This is what is tracking actually. This is like the unique identifier for this entire thing. So the transaction ID, this is what it is checking. When you're trying to check on the duplicates, you're trying to check on this, for example, if there are such instances. So basically, this one is going like to check if there's a duplication of those entire row, that row. That's why it's going to remove. If it is going to have something different, then it will be treated as a different thing. I don't know if that's clear. Remember, we applied the duplicates for the entire data frame, not on specific columns. So it is just checking the entire data frame code with Malon. I don't know if that's clear. Code with Malon before I progress. We are using, in this case, actually, it is checking on the especially transaction ID, because that's the primary key, something that should be very unique. Are we good? Everyone, confirm? Wonderful. I see the number started to reduce. The number started to reduce. The number started to reduce, but let's try to cover something. Actually, today I want us to just complete the I just want us to complete the data cleaning, so that in the next session we're going to begin with the feature engineering. But they usually sometimes have many things. If we get an opportunity, at least we need to use it. I know you have some other engagements, so like if you have some time like this, let's try to use it. And the good thing is there's recording. It is being saved, recorded. So the other thing, we have handled what? The duplicates. And then the other thing maybe that we can try to clean, it is the outliers. The cleaning, then now this is to, let me say, handling outlier. What is an outlier? Anyone in the comment? Let me know. Wonderful. What is an outlier? Anybody? I just want to see if, yes, anyone who know what is an outlier? Let me give you 1 minute. Okay. Also, maybe if you are a beginner, don't worry. We say that we're explaining everything. Basically, an outlier is something like out of range. Let's say, let's say you have a data. Let's say, for example, which example can I use? Which example can I use? Let's assume that maybe you are in the village, and the people, the income, actually the income in the villages are not that high, and then you've been oh, okay, that's not a good example. Let me just say, let me just say, let's say you are recording, maybe you are receiving some data which ranges between, for example, 10 to 100, 10 to 100, like that is the default, or maybe let's assume it's something like marks of students. The marks should be in percentage, which means to be between 0 and 100. Then all of a sudden, you get something like 1,000. So this 1,000 is out of range. So it is treated as an outlier. That's just an example, but in this context, an outlier should be something, something like just out of range. Now remember, we're going to handle the fraudulent transaction. We shouldn't clean. There are some parts that we are not going to tackle because you might be having such a thing because it's part of the illegitimate transaction that we are trying to train the model with. So which means we should retain it, but there are some other fields that we're going to check on before we handle them, so that it doesn't affect what the model. Remember, the data should be, especially this mostly we are dealing with in fact, the outliers affects both the regression, they affects also the classification. So it just need you just need to work on that. So here I can say, let's first of all handle the, maybe there could be an issue. Remember, we said that this data set, it was made messy by default, like intentionally, so that we can learn it in the class. Let's assume that there are some values, there are some amount that are in the negatives. You cannot transact negative transactions. So in the event, for example, we have those ones, we need to convert them to absolute values. So let me say handle. Let me say handle negative amounts, because it's going to like if you are to use something like a regression, it will be like those metrics is going to like sum all the errors. It's going to sum all the errors. If you're using, for example, the mean absolute errors, mean squared error, or root mean squared error, it's going to do it. It's going to sum everything before it handles that. Actually, it usually sum the errors. We call them residuals. If you, I'm trying to illustrate that one with the example of the regression. Like it's going to like sum all of them, and then since there will be the negatives, then it will be squaring those negatives, and then if you want to get now the result you will be getting to be called now the residual sum of squares. If you get now the average, then it's going to be called the mean squared error, and then when you get now the average of those values, it will be now the root mean squared error. Now the absolute mean absolute error, it assumes there are no negatives, like you're using the absolute values. But now in this case, the negatives amount can also have the impact on this one, because we know someone cannot transact a negative amount unless someone is withdrawing. That's when the money will be. Actually, even if it is deducted, it can either go to the debt, but the amount will not be negative. So it is a good thing to clean that. So let me say negative amounts, negative amounts. So this one I will be checking. BF, and then targeting the amounts column, amounts column. So basically on this one, we will be checking those that are first of all, these negative amounts, we want to know which ones are they, and they should be numbers less than 0. Less than 0. So here we will say the numbers less than 0 here. This one is going to filter. The numbers less than 0, and then now we can do a summation so that we can be able to know how much is it, like are those values in sorry sorry are those values that are less than 0, and then maybe we can do something like a log. We can log it, print, and then I can use a formatted string because I want to use variables in the inset. So let me say something like a found found sorry found maybe this is going to be a value, so a negative amount, negatives amount. But they just use I just use the chat section to yes. This is the correct explanation. It's just a value that is too extreme, out of range. Yeah, out of range. Well, I don't have people in TikTok. I don't have like learners. Maybe the audience is not in tech, but it's fine. So negatives amount, and then now these amounts we need to convert them into absolute values. Like absolute value, these are numbers which are positives. So and then amount. I don't know. I hate repeating myself. I should have just copy pasted somewhere. Amount. So these amounts, I'm going to convert them. Let me use this. So these amounts, we are going to make them absolute. You can use the method called ABS. Sorry, this ABS is going to convert those values into positives. We're going to convert it into positives. Should I write it there? Let me write a comment so that someone can. Let me just say convert. To absolute values. We said that what is an absolute value? A positive value, no negatives. So because we know there could be no negative money, especially amount. And then maybe another thing that we can try to handle it is there's a field for the age. So we know someone to use a bank. I remember this assumption is that this data set is about a banking system, something about finances. Mostly it's handled by people who have the national ID. So there should be people with the age of 18 and above. And also, sometimes we don't know if there could be some people above 100 that they can be able to transact. I believe it is impossible. Nowadays, especially at this generation, like when you are 100, you are very, very old. So those are the things that maybe we can try to filter. So let me say remove age. Okay, there's something here. Remember, guys, this one we are just handling the part of the negatives. The negatives in terms of the the amounts in terms of the negatives. Now remember, if it is a positive number but then it is too extreme, then that one we shouldn't clean, or that one we shouldn't update it, because that could be a fraud transaction or something like that. So that one will not clear on the amount. we shall just maintain it the way it is, just on the absolute. We will not handle those extreme values because there could be illegitimate transaction of which we are going to train the model with to know what are those. So, but now on the edge here, I'm going to say now edge outside. Edge outside. Okay, let me just say. Let me say handle impossible edges. So first of all, let me try to print the initial. So for example, before we do that, before we handle them, let's see the initial if there is. Remember this data set I've repeated a million times. We made it intentionally messy so that we can learn these things. So edge range before the clean handling of it is going to be what is the field for that? Sorry, for the edge it is, wait, where am I going? Yeah, user edge, that's the field for edge. So here I'm going to write df then user edge, and remember they must always be in quotes. User edge, user sometimes just go to copy paste than to debug. Yeah, so the user edge, and then we want to identify first of all the mean of the edge. We can okay, let's first of all identify the mean. Let's say mean. Mean is a method we can use the mean to get the minimum. To before we do the update, it is important we oh no, sorry. Remember this is a string here too. Then I'm going to also copy this one. Then this one I'm going to use the max. It's going to give us the max. So it's going to be like the date range before is going to show you the mean. For example, starting from let's say 22, for example 100, 100, so that we can be able to know if there's an issue there. And then now here I'm writing another comment. Now we can remove let me say remove edges outside, maybe outside. Someone can tell me what are the edges we should restrict, up to which one can be ideal, which range. I think it must be above 18. Up to which range I'm going to check in the comment section in a moment. Just tell me, just to make it to have some engagement here. Reasonable range tutumie gani? Which range? Edge range? Oh, the number has reduced greatly. So I think I'll just finish because I need to teach people, by the way. If there are no people, then it means that I will need to stop. Let's just say maybe 18 to 100. 18 to 100, and then so now to target the records, or maybe like to target the column, to target the column and do the filtering on that, we can use the log attribute. Remember, this is not like the dictionary, like this one, pandas data frame. It is different from a series. A series can act similar to a dictionary where you can use the keys, which like could be like a columns to get the values. But then now, since this is a data frame, we'll need to use what? The log attribute. So df dot log attribute, so that we can target the column and then be able to perform some some filtering on it. So user age, user underscore age here will be filtering first of all, because we don't want to have anyone less than 18. We need to have people who have the national ID, and I think most governments usually issue IDs to people that have the to people that have to people. Let me wrap everything here, because I want to perform like people that have 18 years and above. Then user age, I want us to update it, user age, the user age here, we can give it to, first of all, we can, before we, now instead of deleting or maybe giving it deleting the entire row, let's try to give it a proper null value. We can use NumPy for that. np dot nan is an attribute to convert that record to a proper null, like an empty cell, something like an empty cell. From the NumPy, we're using that one to convert like this user age. In the event their user age is less than 18, then that user age we're going to update it to a null value. Sorry. And now the same case to those above or equals to 100, maybe. Is it above? Let me just say maybe 101. Let me say 100, which means that it's going to be 100 and above, or 101 and above. Again, this one we're going to make it not a number. Now, the reason we don't want to do away with it, that entire row, maybe it could be carrying some other information. Maybe they have just mistaked on the age, but other information are correct. So, like instead of doing away with that entire record and can be useful for the machine learning, so instead we can just fill it with an average age, like an age that most people are having there. No, not even the mode, because that would be like mode. We can use the median. That is an ideal. User underscore age here. I'm going to fill. Remember here we have converted them to the empty set to nulls. Now we want to fill those null with what? The median. So df user age. I think sometimes it's just good to copy paste. It's not seen by the way. It's not seen to copy paste. So the user age here will be getting what? The median. We'll be getting the median, and then we can update the data frame by using in place. In place, guys, are just holding there. We are finishing. Don't leave. Actually, I just need to have someone, even if it's just one person. We're going to finish. Actually, I'm just finishing on this part. Yeah. So and then we can try to verify. We can try to verify if this. Now the age range, now this should be now after the age range after, and then still is going to be the min and max. It's going to give us what? That range. And then so this is on the age, but then now we'll need to flag high amounts. Okay, what we will do, because at the high amount, remember this high amount could be fraud. The high amounts could be fraud. We don't want to delete it. we don't want like to do away with that, but we can try to flag it. We can try to flag it to okay, let me just not touch that. Let me just not touch that. Let's just maintain it the way it is. Or let me create a I can create a new column for that. Let me just do that. Let me say create uh, um, a flag column for high amounts. You can create a new columns for that. Maybe at the maybe 99%, 99th. So maybe okay, but now remember these high amounts you need to work with them carefully, because these are what, and that they are very minimal. If you're going to mess up, it's going to affect everything. It means that I will be training your model. Of course, there are several steps we will be covering, including like there's another algorithm we'll be using called the inblan. The inblaning, where we can be able to like generate or maybe have some new records synthetic, and then the existing one we can be able to trim, to remove. But now this few that we have, let me just write here, this might be fraud. We should not remove. Let me say, so don't remove. We can just flag them. We can just flag them. We can just flag them. So we are going to create a new series, a new okay. In pandas we call them series. I want to create a new one, df, and then I can call it maybe I can call it something like is high is high amount. I can call it that. And then now on this one, basically what I'm going to do, we can filter. We can do a filter for the amount. If there's something to copy, I can copy without worry. You know, yeah. So amount, and then now I'm going to filter those that are above. Those that are above the 99th quartile. 99th quartile, I think that could be now the ideal way, and with that we can use the pandas. It has that thing. So df again, no, so because now this is a filter, I want to filter those that are in the above the 99th quartile. That case we can use from the pandas. There's a method called the quantile to create like a some kind of you know those things like the quartile. There's in the quartile, there's upper quartile, then those kind of things. So like pandas, you can be able to create for that for you. Like I can be able to create your own quartile, and in this case it's going to be 99th, so we can use the 0.99. so those are the ones that we want to flag them into its high amount, and then let me just convert it to a proper data type, yes, type, so that I will not, yes, is type. Want to make sure that they are integers. So this is just like to flag them. Remember, we are not removing that one. I have to stress it because we are trying to detect or maybe to identify the fraud. So you cannot remove something that you want to train the model with to know what is fraud, what is not. So here, guys, we are finishing. Here we can say maybe created this column. created is high amount column flag for this one will be for for this one. That's some transaction. Transaction. Yes, just to confirm. Remember, these loggers, guys, are very useful, especially on matters debugging. So make sure at least at some point you are trying to execute these things, like so that you can know what is happening at least. So and then now finally finally, let me just check something here just to confirm something. Yeah, distance from last transaction. This one is very key. I believe, how many have used PayPal before? Let me reconfirm if I still have people. People have left. Yes, thank you so much, Beneza Wange and Codid Malan. Wow, not ametoka, people have left, so let's just finish. Yeah, so if you've used PayPal before, you'll see, like, for example, if you are not active on PayPal, then all of a sudden you are receiving thousands or maybe intense transaction within some short period of time. They will flag it and they can hold it to some particular time period. So we can try to cap extreme distance. Maybe if you are not selling much, or maybe if you are not transacting much, we can be able to flag that as well at the still 99th percentile, still percentile. So for that one, I think I can just copy something and then I can copy this one, then I'll just be changing. Let me just copy something here that is very tricky to type. Distance from last transaction is very hard to type. I just copy. So this one, we are going to, sorry, let me call it, or let's have first of all a logic for that. Let me say distance underscore cap. Let me just first of all write here before I forget. So this one I'm going to use the df data frame, and then now that column for the distance from the last transaction will be checking on the 99th percentile, which now should be if you want to make them in those quantiles, for example, you'll need to use that method we used earlier, quantile, and then here should be now on the 99th percent, but then now you need to write 0.99 because it doesn't know percentage well, like this modular, so you need to write it in unconverted. It's much more easier. So now on this one, basically this one will be updating the okay, we're trying to create a new column, and then now the value that I will be filling it will be these ones which we can clip distance from the previous transaction. Then here we can use the we can clip them to the upper this distance curve. I think yeah, so that's fine. Then here maybe we can try to log here. Let's say something like cut maybe distance distance at sorry distance at this one, this distance, that quartile here we can use into 2 decimals. Yes, so these are the distances from the last transaction. Let me run and see if we're going to get the error. So we're getting the syntax. Oh yeah. So where was that? Where was that amount to absolute? That where I have the that comment to absolute value. Where is that? To absolute. Where did I? Yeah, here it is. Okay. I forgot. We were to update it to a new one or give it a new values, the absolute, to make sure that all of them they are positive value. Let me run it again. All right. So it found 100 negative amounts. You know, like this is very serious negative amount. So then the age range you have there negative 25. That's like at the minimum. By the way, this one we had to do this. We had to clean. But now here we are getting this error on the log. The log attribute. Where is that? This log here on the user age here. What could be the issue? Let me see. Is not supported between instances list and the integers. Okay, not the problem. This should be a data frame. I forgot. This should be a data frame. The column user age. The column user age. The column user age. But you guys also need to, you know, sometimes when I talk and type, sometimes I usually confuse. So make sure that in the event, for example, you get an error, you inform me. Okay, but there you are. Yeah, so I think it has worked. So now the reason we are not getting this one because it is updating the data frame. So I will need to save it again. Just to confirm, guys, I'm saving it again and then I'm going to restart so that you can be able to see what has happened. Remember, again, I said that this one does not affect what? The original data frame. No, the original data set. So when we are going to restart, it's going to run it again. So we are going to see its initial state. That's very important. So I've saved it. Then let me restart the notebook. And then once I've restarted the notebook, guys, we are finishing. I'm going to run all the cells. All the cells. All the cells. Yes. So you can see now we found 100 negative values. We found 100 negative values, of which those negatives we converted them later to absolute. So that's very important step to do. Remember, this part is also very key. And then also the age range, you can see here we had the age which was negative 99, negative 25, and then up to this age. Actually, Methuselah in the Bible lived, is it Methuselah or someone? I don't think even they lived this many years. Yeah, so these are the field data. We had to make them nulls. Then now the new values. The minimum age is going to be 18. Now the maximum is going to be 100. Then on the 99th, sorry, 99th quantile, we had these ones. So these are the records. But remember, we didn't like deleted them. We just created another column that's going to flag them as like that has an issue, or maybe it's high amount. Remember, the output is going to be true or false. So these are those values, and then now the distance which was capped is up to this one. These ones up to the 99th percentile on the distance. So this is what we have capped. Now remember, we haven't finished on the data cleaning, but I see the response is low. Like people are very few. Or guys, can we just can we just Nini, I finish on the last part, last bit on the. Actually, we can do it next time. There's no pressure. Let's just do it next time. But then there was that last part on the handling. Remember, we've done the cleaning mostly on the numerical column, but as well, we'll need to also address the categorical or maybe the text column. That was to be the last thing to work on. Then after that, we'll be going to the feature engineering. But I also feel like we started at 8 p.m. that's Kenyan time. So it means also guys you are tired. Let me just accept people are tired. I guess we're going to start from handling those categorical data. It will be just something small similar to this one. And then I will go to the feature engineering. We'll be handling the feature engineering. It's also a very, very key thing on machine learning, feature engineering. That's where we're going to spend a lot of time. And then after that, since now machines only understands what numbers, then we will need to do the encoding. We need to encode like the text column. We'll be able to encode them to numbers. And then after that, we'll be preparing the data for the modeling, like dropping unnecessary, columns which will not be required perhaps on the modeling, and also separating the features from the response variable, which in this case it is fraud or not. Like actually this is the column. We'll be separating that from the features, and then that is still on the preparation. Then we'll need also to split our data set. Sorry, we'll need to split our data sets partly into training and testing, and then we will be doing the I think that one could be enough. And then of course there will be a point where we'll be scaling, because we have data which varies the range or the scale, so there must be some standardization. I will need to do that feature scaling, and then after that, then we shall handle those imbalance data. Remember, this is a fraudulent, or maybe we are trying to implement the fraud transaction, fraudulent system. So, and we know the ratio, actually the percentage was less than 2, I think it was 2% of the data. So it means it is very, very imbalanced, very, very imbalanced. We saw that one earlier. I don't want, yeah, it is 2.20%. So we need to work with them to handle the imbalanced data, and then later we'll begin now to train the model with several ones. The one that we have imported here at the top, we'll be training them with the random forest. We can also train it with different others models. Then later we shall be evaluating our model performance. For example, if it's not performing well, then we'll try to handle also something called the parameter tuning. We'll be talking about that. And then once we are confident that the model is performing very well, then now we'll proceed to build an interface that normal people can be able to interact with, like something like ChatGPT. When they tell you like it's a model, for example, 2 point, for example, the particular version, let's say ChatGPT 4 or whatever, that's just a model. Like a normal people, they don't know the complexity behind it. For them, they just want to see a very simple interface, the input field, where they can write there the prompt, then the system is going to produce the result. So the normal people, they don't want to know the code. They just want to have a simplified interface to interact with what? With your solution. So after we have trained that model and we have tested it works well, then we shall serialize and then we'll build now the system with Django, and then we can use a framework like Next. We will use React because of this one, most of you use it. And then now I will be good to go. Guys, there's some steps, but I believe you guys are learning something, right? Are you learning anything? I hope it's not a waste of time here. I've left many things. I just hope, guys, you are learning. But if not, you can also tell me so that we see what to do. Wonderful. I see. Yes, we are. Yeah, wonderful, wonderful. Yeah, this is great. Wonderful. Actually, today we had 89 views. Wow, we are increasing. This is amazing. This is amazing. This is amazing. I think it's an encouragement. If someone is learning, and then it means we have done something. So, guys, basically, this is it for today. I am also feeling tired, and I also need to rest, and I also need to practice what we've done today. Remember, it's not a must to be this data project, could be something else, but then now the flow is the same. Make sure that we're using the same flow is a best practice to follow this entire thing, especially on the data preparation and cleaning. That is a very, very crucial point in everything. Remember, in the machine learning, when you be training the model, we can just use something like this, like a few code like what is in this cell. But data preparation, we began from these are the step all the way to the bottom. Like there's a lot of time on the data preparation. So building the model is very easy, is like the easiest thing. But now data engineering is where there's a lot of work. So make sure that you are following all these steps to make sure that the data integrity is very high, because the poor quality data, it will give you the poor score. When you'll be evaluating, you'll not get the best score. So like the data should be of high integrity. When you build the model, it's going to be very perfect. It's going to be very, very perfect. So guys, this is it for today. This is it for today. We meet next time, hopefully. If there will be no issues, we'll meet next time. Until next time, have a great